All right, welcome back. So during today's time, we'd like to complete exam 2. And it should only take you about the time duration of this class. As long as you've been following along the lectures, it should be straightforward. This exam actually is really important. So it's not just to give an exam to make a grade. This is actually very critical, I feel like, in the learning process of your fine elements. I feel like this is going to solidify everything we've done up to now and just give you that perfect base to do lots of more application of fine elements in your career, wherever it might be. So I hope that the way that this exam is designed is to build that base. All right, so it's not just to waste your time. We are going to do something that will be similar to what we did in lectures 27 and 28, and that is create a problem that looks like this, both by our hand, and by hand I mean the MATLAB file that we used and modified, and then we're also going to create this in Abacus. And again, we're going to try to, like we've done in previous lectures, we're going to actually try to verify and confirm for ourselves that Abacus is doing what we expect it to do in terms of theory. All right, because we don't know what's in Abacus. It's a black box. When you use it out in your career or in the workforce, it's a black box. You're not going to have source code to it. In our case, we understand what's in the source code. We understand what is programmed into that, and we want to demonstrate that here. All right, so that's the purpose of this exam. There are a couple things I need to note. First, that I can tell you the spoiler alert is that Abacus should give you the same result as your MATLAB hand calculations. Okay, so you should get very small errors, and when you turn it in, you should know that you have 100% essentially because you have the same solution. So that's point number one. Point number two is that hint is that you should really use the partitioning method that we've gone over in a couple of applications to partition this geometry. Okay, so you have to program in and make this geometry, but when you do that, you actually have to have partitions on these mesh lines. You want mesh lines along here, right? So you would give something like a mesh seed of equal to 1 that would allow just one element to be created in each one of these. You only want 3 elements, as you can see, 1, 2, and 3, and they don't necessarily need to be numbered like that, by the way, but you do want to use the datum lines and partitioning like we went over to create this geometry of the mesh. So that's like a little hint. I've seen some students actually try to mesh this. They just seed the whole thing and they just play mesh. You can't do that. You'll get a bunch of different elements in here, or you'll get an element that Abacus will create like over in this direction. We don't want that. We want to be very specific on where those mesh lines are. So the partition helps you do that. Okay, finally, I suggested a format in this packet that you can use. You want to be clear, and I want to see a nice polished PDF when you upload it. It helps me grade it easier and help me get through these extensive work that you're going to do quickly. So I really appreciate that. All right, with that, let's get started. I hope that you actually enjoy this exam. I hope that you feel like you know the knowledge to do the work quickly. As always, feel free to reach out if you have any questions or if anything with ACI is not functioning. Please let me know about that.